And finally, from section 4.7, we have on page 386, number 55, and we're just doing parts A and B. So what we're looking at is a hot air balloon that rises from the ground to a point 500 feet away on level ground. So we're asked to write theta as a function of the height s of the balloon. So here I have a right triangle with my balloon up there, and I have theta marked in my 500 feet, as well as the height s. So if you're just using trig, what you notice is we can describe theta in this way, that the tangent of theta is equal to the opposite side s over 500. So if we want a function that is theta, we're going to take the inverse. So our answer for part A is going to be theta will equal the inverse tangent of s divided by 500. So now we have a function theta in terms of the height s. Now for part B, we're asked, is the change in theta greater as s changes from 10 feet to 20 feet or from 200 feet to 210, which in both cases is a change of 10 feet in height. So the best thing to do is to take our inverse tangent function and put in a graphing calculator and evaluate it. Or you can just put in those values for s in the calculator and look at what the value of theta is. So I went ahead and did that. I put inverse tangent of x over 500. And if I look at the graph, what I can see is that, let me change my scales here. I want to go from 0 to 500. Oops, 0 to 500. And I'll count by 50. And then I can leave my y's alone. Actually, I'll change those from 0 to 180. I'll make it 90. So the other thing I have to do, since I'm talking in terms of degrees, is change my radians to degrees. So I'll do that. And then I'll look at the graph. And I can see that it looks linear, but as you see near the end, it's going to level off. So it's probably steeper, and the change is greater in the beginning. So let's take a look at the table, and we'll see where we are. So at 10, so here's 20, since we're right here. At 20, the value is 2.29 degrees, and at 10, it is 1.145. So let's write those down so we have them. So at 10 degrees, we're at 1.145 degrees, and it changes to 2.29 degrees. Okay, so that's from 10 to 20 feet. And then from 200 to 210, and I know there's a way to change that on the screen, but I'll admit that I do not know how to do that. So I'll just have my table start at 200 feet, and I'll go to my table. I'll be right there. And at 200 feet, we're at 21.801. And at 210, we can see on the screen, is 22.782. So let's write that down as well. So now we have 21.80 degrees to 22.78 degrees. So the change is greater here because this is almost double, whereas the degree change might be as much, but the percent change from 21 to 22 is a lot less than it is from 1.145 to 2.245. So the greatest change is going to be the first one, from 10 to 20 feet.